Hello friends, myself R.D. Mahajan presenting my video on beta gamma function. Let us prove that integration from 1 to infinity of xs to n by 2 minus 1 divided by 1 plus xs to n and its integration with respect to x as 1 by 2 beta of mn. And therefore, to prove this in terms of beta, either we convert in the definition of beta function first form or second form. Here we try to convert it in this form. We know that we try to convert in this form beta of mn as integral from 0 to infinity xs to m minus 1 upon 1 plus xs to m plus n. And to convert in this form, we consider this as I. Let I is equals to that given integral. Integration from 1 to infinity xs to n by 2 minus 1 divided by 1 plus xs to n and its integration with respect to x. We call this as equation 1. In this equation 1, we substitute x is equal to 1 by y. This is standard substitution. And then differentiating it with respect to y, we get dx is equal to derivative of 1 by y is minus 1 by y square and its integration with respect to y. And as we are using the substitution, we try to find out the new limits. From this we get the value of y as 1 by x. For x is equal to 1, we get y is equals to 1 by 1, we get y as 1. And for x is equal to infinity, we get y is equal to 1 by infinity. 1 by infinity is 0. And then substituting all this information in equation 1, equation 1 becomes therefore we get that as I is equals to new limits. For 1 we get 1 and for infinity we get 0. The value of x is 1 by y that raised to n by 2 minus 1 and whole divided by 1 plus x. X is 1 by y that raised to n, and dx, the value of dx is minus 1 by y square and its integration with respect to y. Then cancelling that minus sign by changing the limit as per the property of definite integral, and therefore it is from 0 to 1. Then combining these two terms of 1 by y, therefore we get 1 by y raised to n by 2 minus 1 and plus 2 and whole divided by, finding LCM, we get here y plus 1 divided by y and that raised to n and its integration with respect to y, and that is equals to again combining these two terms of 1 by y and then making it as y raised to. Therefore, if you try to write them as y raised to, we have to transfer this to numerator. It becomes y raised to minus of this term, and therefore it is integral from 0 to 1 y raised to 1 by y. I will write down as y raised to minus of. Therefore, minus of this means it becomes by y means y raised to n. Then this becomes minus n by 2, and 2 minus 1 is 1, and minus of that we get minus 1 and divided by 1 plus y raised to n. N I will split as n by 2 plus n by 2. And therefore it is equals to integral from 0 to 1 n minus n by 2, we get n by 2 minus 1 divided by 1 plus y raised to n by 2 plus n by 2 and its integration with respect to y. We know the property. Definite integral does not depend upon the variable. I can convert y as x. Therefore, in terms of x, it becomes integration from 0 to 1 x raised to n by 2 minus 1 divided by 1 plus x raised to n by 2 plus n by 2, and we call this as equation 2. Therefore, we have two equations, equation 1 and equation 2, I on left hand side. Therefore, if we combine this, we get 2i is equal to integral from 0 to 1 plus integral from 1 to infinity with same integrand as x raised to n by 2 minus 1 divided by 1 plus x raised to n by 2 plus n by 2. We can combine that two integrals. Therefore, next step, 1 plus 2 we get. Therefore, combining equation 1 and 2, we get addition of left hand side as I plus I as 2i, and adding right hand side term, first term is integral from 0 to 1 x raised to n by 2 minus 1 divided by 1 plus x raised to n, nothing but sum of n by 2 plus n by 2 and its integration with respect to x, and plus second integral, it is integration from 1 to infinity x raised to n by 2 minus 1 divided by 1 plus x raised to n. Again, I can write down that as n by 2 plus n by 2. Same integrand and limits are 0 to 1 and 1 to infinity. Combining these two, we get limit as 0 to infinity. 1 is in between 0 to infinity. And integrand is x raised to n by 2 minus 1 divided by 1 plus x raised to n by 2 plus n by 2. And then its integration with respect to x. And then comparing this with this form, 0 to infinity, yes, we have 0 to infinity. Some x raised to m minus 1, x raised to n by 2 minus 1, and divided by 1 plus x raised to m plus n, n by 2 plus n by 2, is nothing but, as per definition, it is beta of mn. M is n by 2 and n is n by 2. Therefore, 2i is equals to this one. Dividing by 2, we get the required result I as 1 by 2 times beta of n by 2 n by 2. And I miss this integral. Integration from 1 to infinity x raised to n by 2 minus 1 divided by 1 plus x raised to n, and its integration is 1 by 2 times beta of n by 2 comma n by 2. Simple proof, only you have to remember the standard substitution. We have to use the substitution x is equal to 1 by y. Then one more proof I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel to receive notification for my new videos. For that, you have to press the bell icon. Thank you very much.